Welcome to this eLearn security video lesson on network security post-exploitation, exploiting unquoted service paths. In this video, we are going to cover a method we can use to escalate our privileges to system using what are known as unquoted service path vulnerabilities. Unquoted service path vulnerabilities abuse the way in which Windows searches for the service binaries prior to launching a service, and when a particular path to a service executable is unquoted and contains spaces. As we saw in the lesson content related to this video, unquoted service paths can be used for persistence to a system, as well as being used to escalate our privileges depending on the configuration of the service and permissions of its associated service executables and directories. For this video, we assume we've already obtained access to a target system and are currently a low-privileged user. In this case, we can see we have an active interpreter session as user Travis on a target Windows 7 system. Let's first interact with our current session and drop into a shell so we can start our post-exploitation activities. First, we need to identify a vulnerable service. To do this, we can use the WMI command line tool, WMIC. Using WMIC, we can query all services and their associated service binary paths. This command will specifically search for service binary paths which are unquoted and can help us quickly identify services and paths that we can use to our advantage. As we can see, our WMIC command has found a single service on the system configured with an unquoted path, the vgauth service, and its associated vgauthservice.exe executable. Now, due to the way Windows will search for the executable path, we have a couple of options in regards to where we can drop our payload binary. From the above WMIC output, a good candidate for this would be c:/programs-files/VMware tools directory. We should be able to drop our payload as a file named vmware.exe within the VMware tools directory. But before we do that, we should first confirm our user has the ability to stop and start the service. We'll use the scstop vgauth service command, followed by the scstart vgauth service command. If we're able to stop and restart the service, this should be enough confirmation that we can manipulate the service and continue with our task of exploitation. We've confirmed we can stop and start the service without errors. We should also confirm our service will start as the local system account. We can use the seqc command along with the service name. The service_start_name is set to local system, and this confirms our service will run as system. Now that we've confirmed we have permissions to start and stop the service, let's stop it for now and move into checking the permissions of the directory we'll need to write our payload into. Once we're in the VMware directory, we can then use the icacls command to check folder permissions. We're looking for modify permissions for the VMware tools folder, since we'll need to upload our payload into that directory as a file called vmware.exe in order to exploit it. From the icacls command output, we can see that the authenticated users have the ability to modify the contents of this directory. We can see that with the M value. So far, we've confirmed we can stop and start a service affected by an unquoted service path. And we've also confirmed we can write to a directory we've identified being within the search path of the service. Now that we've confirmed a few things, let's upload our payload to the VMware Tools directory as a file called vmware.exe. We already have a 64-bit payload binary we've generated with MSF Venom and with a Meterpreter reverse HTTPS payload. First, we'll send our current shell into the background with Ctrl-Z, and from Meterpreter, we'll use the upload command to upload our payload as a file named vmware.exe to the VMware Tools directory. Once our payload has been uploaded, we need to make sure we have a listener ready to accept the new connection. We'll send our current Meterpreter session into the background with the background command and confirm that our multi-handler is configured with the same payload, lhost and lport, as our payload binary. Once our handler settings are confirmed, we can use the exploit-j command to start up the handler. Now that our handler is ready, and our payload has been uploaded as a file named wvmware.exe to the VMware Tools directory, we should be able to start the service and see if we get a system Meterpreter session. Let's interact once again with our existing session, drop into a shell, and start the vgauth service. Once we start the service, we can see that we have obtained a new Meterpreter session on the target. We can try and interact with our new shell. We can first background our current shell with Ctrl-Z, background the current Meterpreter session, and interact with our new session, which is session 2. One thing we'll immediately notice is that although we've obtained a new Meterpreter shell, it appears that the process is unstable and may have crashed. We can usually tell because running a typical commands using Meterpreter will fail with various errors. In this case, we get a timeout error when trying to interact with our new Meterpreter session when simply running the getuid command. We can remedy this by launching our handler with an option known as AutoRunScript. As an additional option to our handler, we'll use the setAutoRunScript option with the migrate command and the -n parameter to migrate our payload to an existing svchost.exe process. This should give our payload some stability and allow us to interact with it. First, let's background our current Meterpreter session and configure the handler with the AutoRunScript option, and rerun the exploit-j command to start the handler again. Now, we should interact with our initial low-privileged Meterpreter session, drop into a shell, and try to start the service once again. As we can see, we've obtained a third session and have successfully migrated to an svchost.exe process. This time, our new session is hopefully a bit more stable than the last. We'll send our existing low-privilege session into the background again and interact with our newly acquired session. And we can see, running the getUID command again, we can now interact with our new, stable Meterpreter session. We can now proceed with additional post-exploitation tasks. And this concludes our video lesson on network security, post-exploitation, exploiting unquoted service paths. Thank you for joining us.